All right, everybody, let's talk about polynomials. We're starting off our next chapter, chapter 2 for us here during algebra. And we're going to talk about polynomials, and that will lead us into our exponent chapter. So polynomials, we can define them as an expression consisting of many terms. Now, many can mean as much as just one. It could also mean as many as 5 or 6. We'll talk about what that looks like. To write things, though, in standard form, we've talked about the standard form of linear equations, right? That ax plus by equals c was our standard form, and oftentimes we use that when we talk about word problems. However, we in this class have only used it to switch over into our slope-intercept form of an equation. Polynomials also have a standard form, and you should remember that they must be written in alphabetical order. But they also have to have the highest degree first. Well, we all know what alphabetical order means. That means we're following that A, B, C. So a lot of times we might see this with X and Y. Knowing that X comes before Y in the alphabet, we'll want to list our letter X's before anything else. However, the highest degree might be something new that you haven't heard of before. And when we talk about degree is the same as the exponent. In the past, you've maybe known just squares, or this 3 like our example here. That means cubed, and we'll talk about some of the other names once we get into that a little bit farther. But for this example here, our highest exponent is called degree of 3. So we have our highest exponent, that's our degree. And like I said, for this one, our biggest exponent is 3. So you'd say 3 is the highest degree. Now, when we classify a polynomial, there's 2 things we need to remember. One thing is we're going to name it by its degree. So a constant term would just be a plain number, so it has degree of 0. So we could think of this as like 2x to the 0. Well, anything to the 0 power is just going to be 1. So this comes out to be just 2. So anytime you see just a number, that is a constant term. Its degree is 0. For a linear, that's very similar to the last few chapters that we talked about with our review chapter. That would be something like x plus 5. It could just be y. Could be any number of just the highest thing being just one letter. But a quadratic is something that we oftentimes see as squared. So its degree is 2. We could have z squared plus 5. That would be a quadratic equation. A cubic, very similar. Its exponent or degree is going to be 3. So we can have a3 minus a. That would be a cubic equation example. Quartic, same thing. We're going to have our highest degree as a 4, but maybe this time it's plus 5a squared minus a, something like that. We can mix and match different letters in here as well. Just remember that when we write these, they want to be in alphabetical order and the highest degree first. We also, when we classify polynomials, we talked about the degree. We also go by number of terms. So how many things are in this polynomial are listed by, if it's just one thing, we call it a monomial. So if we have just our constant degree, that will always be a monomial. It can only be one thing. Sometimes, though, we could have a quartic monomial if it's just a to the 4th. That's just one thing in our entire sequence, in our entire polynomial. A binomial is when we have 2 things. So like this z squared plus 5. That's a binomial. I could have z to the fourth, or quartic, with just two things. That's a binomial. A trinomial would be three things. It could be z cubed plus z minus 2. As long as it has three different things that we can't combine, that would be our polynomial. That would be called a trinomial. And anything that has four or more things in it, separated by either a plus or minus sign, remember that timesing makes it the same group and dividing makes it the same group. So as long as it's separated by plus or a minus. Now, there's a couple of other things I want to talk about before we move on to our examples here. We also have what's called a leading coefficient. And that leading coefficient is going to be whatever number is in front of that highest degree polynomial. So if I were to have something like 3x squared plus 5x minus 2, our leading coefficient here is the 3. We have our highest exponent of 2 and whatever coefficient is in front of that. So in this example, our leading coefficient is 3. We might also be asked what the constant term is. The constant term. Using the same example, a constant we said is whatever number doesn't have the variable, and that's the same thing when we're given a longer polynomial. It's whatever number does not have a variable with it. So in this case, our constant would be -2. Let's talk through some of these examples and get into a little bit of what your assignment is going to look like. We're going to be asked to classify the polynomials by degree and number of terms. So let's keep this chart handy up here to help us with that. The first one, we have just 6. Now remember, there's no variable. It's just the number. There's just one thing. That means that we have a constant term. We can write this as 6 times x to the 0, right? 0 as our degree gives us a constant. And anytime we have a constant, the number of terms is going to be just 1. It's a monomial. Example 2, we have -2x. Whenever you see just one variable, that means the exponent is just 1. If it doesn't tell you what the exponent is on your variable, that means it is one of those variables. In this case, 1 degree is linear. And we have just one thing again, that's a monomial. How about this next one though? If we have 7x plus 1, well, we said that x to the 1 is going to be linear, and we know that that's our highest degree. Nothing else in here is higher than 1. So we have linear. And then we have 2 terms this time, so we're working with a binomial, remembering that bi means 2. We have a binomial. So I'm going to go ahead and do these couple other of examples, and so you can practice these 3 and see what you get for an answer. If you need to pause the video here, you certainly can, so that you can test out your skills so far. All right, so hopefully you got the same things that I did. We had a quadratic trinomial, a cubic binomial, and a quartic polynomial. So a lot of this just has to do with recognizing the highest and being able to count how many terms or groups are in this polynomial. All right, let's move on to the second grouping here. In the second part, we want to rewrite these so that they're in standard form. So remember that standard form, we're doing the alphabet and highest degree. Highest degree and the alphabet. So the first thing though we have to do is we always want to make sure that we do the highest degree. So I should put a 1 by highest degree. Second, we do the alphabet, okay? We always want to say whatever our highest degree is, because that highest degree will give us our degree typing so that we can classify our polynomials. The other thing I have here is that we want to state our leading and constant coefficients. So there's a couple of things I need to bring up with these examples here. So when we write these following polynomials, we said alphabetical and then highest degree. For example 7, thankfully, we already have just x. So all we have to do is order these in terms of highest to lowest degree. Well, we talked about if it's just an x, there's 1 above it. And if it's just a number, this is x to the 0. So that means our x2 has the highest degree, so we'll do 2x squared. X to the 1 comes next, so plus 3x. 1 is the final thing. Our constant term is always going to be last. So writing this in standard form, we get 2x squared plus 3x plus 1. I've also added, though, that we want to state the leading coefficient and the constant term here. So for our leading coefficient, it's whatever number goes with our highest degree variable. So in this case, we have 2 for our leading coefficient, and our constant is whatever doesn't have a variable on it. So that would be just 1. I want to jump ahead down to number 11, though. Number 11, we want to put this in standard form. And if you'll notice, we have A, B mixed up or grouped together in this example. So for number 11, like I said, we want to do alphabet and highest degree. However, sometimes that can be a little wonky when things are paired up like this. So in this case, we want the alphabet to come first. We always want to list what the alphabet would be. So for number 11, we have A, and A. So we have all of our A's together. I want to list my A terms from highest degree to lowest degree. So we notice we have 3 as the highest here, so we'll have A to the 3rd. A squared would be next, so we'll have plus 5A squared B squared. Then we have 2AB, so we'll add on our 2AB to finish off our A's. The last thing we have is our minus 2B cubed. So we want to list them in alphabetical order and then go from highest to lowest in their specific numbers, okay? So we've listed this in standard form. Now we want to say what the leading coefficient is. And since A3 is our first part, we'll say that this has a 1 for its leading coefficient. Remember, if there's no number in front, the number in front is 1. I'm saying that I only have 1 A to the 3rd. So my leading coefficient is 1. For this one, though, there isn't a term that doesn't have a variable with it, so we would just say none. If we were asked to classify what type of polynomial this would be, that's where things get a little bit trickier. We know how many groupings it has based off of our chart up here. If it's a monomial, binomial, trinomial, or polynomial, well, we have 1, 2, 3, 4. So this would be a polynomial. But the degree is where things get tricky because of having these double variable groups. When you have double variable groups, what we're going to do is we're going to add these exponents together. So instead of A3 being what gives us our degree typing, now it's actually A2 and B2, because together those give me a degree of 4. So since I have a degree 4, we now have a quartic polynomial. So quartic polynomial, I've abbreviated there to save myself some room. Now I'm going to fill in what we were looking for here for the last couple of examples. So this would be another great place to pause and practice those examples. All right, so here would be the final answers here for writing our polynomials in standard form and then listing their leading coefficient and constant term. Now we want to talk about how do we actually group these things all together. Well, just like when we were talking about our linear equations and making sure that things are grouped to be the same, we can actually add and subtract these polynomials from each other. So let's take a look at a couple of examples. So for this first one, we have 18x minus 2x squared plus 15. And then we have 3x squared minus 10 minus 8x. So what I want to do is I want to group these with their types, and I like to group the same type of exponent as the highest exponent and then working my way down. So I'm going to have minus 2x squared and 3x squared, remembering from our last discussion that the highest exponent would be 2 because of our 1 and then no variables here. So with that, if I have 3x squared plus a negative 2x squared, that would give me just x squared. Just one x squared is left over. Now, if I look, I have my 18x to the 1 and a minus 8x over here. If I have 18x plus a negative 8x, that would give me 10x. Finally, we have our constant terms, the things without any variables to them. 15 plus a negative 10 will give me a positive 5. So the reason why I do things by the highest exponent first and not just working my way left to right like that is because I already have my answer in standard form. I don't need to rearrange anything. So this would be my final answer for adding those two polynomials together. However, I can also subtract these polynomials, which can be a little bit tricky because you have to remember we're subtracting the two from each other. So first, I have my 6x squared, and now I want to subtract whatever x squared I have over here. So we're going to subtract 3x squared from 6x squared. Well, 6 minus 3 will give me 3x squared. Now, the only other thing I have over here is my 7x. So I'm going to subtract 10x from that. 7 minus 10 will give me a negative 3x. And that's everything from this left side. But we're not done yet because we still have a plus 2 here. The problem is that we have to minus a positive 2 from no other constant. In other words, we're distributing this negative over to 2, and so we're going to just subtract 2 from everything. Again, I like to do these in the highest to lowest degree because my answer is already in standard form. Now, down here I have a few examples of some different problems. If you would like to solve them and see if you can't figure out what the little saying would be up there, you definitely can take the extra practice to do that. However, there are 12 problems for you to do in Delta Math for today, so make sure that you practice with those problems. If you have any questions, please send me an email. I'm more than happy to help you. And make sure to study up for your test if you have not already taken it. With that, have a great rest of your day, and I'll see you tomorrow.